gireceğiz yani. Okay. So, in this week, we will talk about the introduction to neural network. Okay? My English is okay with you? Okay. That's everything is clear. That's okay. 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 So, firstly, we need to talk about the neurons and brain. Okay? In order to understand these things, we need to talk about the physiology of the brain. Okay? Because the main contribution related to the neural network is directly related to the imitation or emulation of the brain structure. Okay? And so, in basic, in physiology, we have some neurons like this one. And so, each neuron has the nucleus. Okay? This is the basic structure or the design pattern for the specific neuron, because if we have the nucleus and then we can transmit any data in the physiology, this is the current values of this thing, and so we can trigger any events based on the coming currents. Okay? For example, if we have any currents in here like this one, I, and I, and so we can trigger any data, or in physiology, the currents. Okay? And so each nucleus have the specific threshold, which means that if we have the sufficient voltage, and then we can trigger the current from the nucleus. Okay? And so this is coming from the I, and so we have in total 3 ampere. Okay? And then if we have the 2 ampere threshold in here, and so this nucleus triggered some other current in here. Okay? This is called the axon. Okay? But this is not enough, because this axon have some dendrites like this one. Okay? And so each dendrites have specific currents like this one, 1.5 ampere, and so these dendrites is directly transmit or connected with another nucleus. Okay? And so this nucleus also have the axon. Okay? Nucleus, and we have some gap in here. We call it in physiology as a synapse. Okay? And so each synapse has a specific region or the empty space in order to in order to determine how much current should be transmitted from the one nucleus to another one. Okay? This is the basic characteristics. And so in each learning phase in your brain, this synapse is shortened or lengthened, these blocks, and then we can learn the things or the thoughts or the objects. Okay? Yes. Yes, in physiology, this synapse can determine its empty space by using this current value. In the nature, we have the minimum principle. In the first week, we have talked about it. Okay? And so, if we want to analyze or seize any objects, and then the brain can learn this synapse empty space. Okay? Okay? But in an automatic way, because we don't know how can we learn this synapse empty space in here, shorten and lengthen, or how much current should be transmitted into another one, but we can do that. But we don't know the main mechanisms of these things. Okay? And so this is the physiology, but in mathematical notation, we can show this physiology or the neurons like this one. We have some specific function block in here like this one, and then we can put some data x0, which is called to the threshold values of our perceptron. Okay, this is the standard perceptron definition, which is directly related to what the one neurons. Okay, and so if the nucleus have the threshold value, and so we should add some bias in here in order to trigger to the what, the currents or the voltage. Okay, and so if we have some paths in here, 1, 2, 3, each path can be modeled in maths as a one variable, like x1, x2, and x3. Okay, these are called the feature, and in geometry we have an axis for each variable, x1, x2, and x3. Okay, because these are the inputs of our model. You can call it the perceptron or the neurons. Okay, and so these hold the features, and we have the feature. Okay, and then if we have the nucleus in here like this one, and so we have the specific function in here, because if we have the higher voltage value than the threshold one, and so we can trigger these things. But in math we should model it with some specific functions. Okay, and so this output can be considered as the y is equal to hx. Okay, just remember that in the last week we have talked about the h value. For example, it's called specific the hyperplanes. Okay, but in this case we should give another function to model the physiology of the brain. Okay, and so these values could be 0 to 1, or could be minus infinity or negative infinity plus the positive infinity values. Okay, you can determine the condition of these output values. Okay, and so in mathematical notation we call it this nucleus as an activation function. Okay, in neural network structure we call it like this one. Okay, so in basic meaning we call it a perceptron or neuron. Okay, this is the standard definition of the one neurons in the brain in the mathematical formation. Okay, but why do we need to do that? We need to create a specific map between the input x to the output y. Okay, because if we can trigger to any neurons in here like this one, and so we can decide the conditions of the output based on the inputs. Okay, map means that in the mathematical theory we have always this notation like this one. For example, y is equal to a dot x square plus bx plus c. Okay, and so this maps the x value into the y one, but the map in mathematical formation more likely related to the geometry. Okay, because if we have any feature in here, this is the axis of the hyperplanes or some mathematical notation in geometry. Okay, and so if you want to create some decision or perceive any other things in here like this one, and so we should map into another one. Okay, and so if we have the gas oil And so if you want to convert the price value, and so we map this price or oil to the price or otherwise. Okay?
Right input to output. We can say that is the right input to output.
Yes. This is called the map. Okay? But in brain, we have more complex structure. Like this one. In physiology, we have some input points in here. And so we have more nucleus or neurons. N1, N2, and N3. Okay? And so each input is connected with the what? With the specific neuron, like this one. Okay? There's a million connection in your brain. Okay? And so each neuron generates to the what? The axon in here, like this one. And so these axons also have some connections in here. And so we have this kind of relation. Okay? And so also we can create the what? The some other neurons in here, like this one. Axons can be given in here. Okay? Or more likely we could create in a simple way the one neuron in here, like this one. And so we have all the connections into this one. Okay? So this is the neuron 4, and we have an axon in here. Axon, axon, axon. Okay? So in this formation, we need to understand that these inputs x1 and x2 maybe and I. For example, if you want to see the anythings, and so you should direct the C's on these things, and so these things converted into the what? The electrical current from the eye, and so this transmit into the what? To your brain. And so this x1 can be called to what? The eye. Okay? Because it's the sensor. Or noise. Okay? And then if you decide to anything in your physiology or in your body, maybe we can drive the what? Your muscle, your heart, or your thought. Is that right? And so if we take the input from your eye, and then we can put your arm in here, like this one. Okay? This is the basic structure of your what? Your brain. So in order to run this system or efficiently use this system in here, each neuron has specific function, which means that Zi is equal to the what? 1 divided by 1 plus exponential minus theta transpose x. And so we should say that this is the Z1, Z2, and Z3. And so each Z1, Z2, and Z3 produce a current in here, like this one. I4 and plus plus I9. Okay? And so this each input converted into the what? To another input. X4, X5, X6, X7, blah blah blah, X12. Okay? And so this nucleus or the neurons can be considered or the model by using this function, which we call it the sigmoid function. Okay? And so this could be a sigmoid or tangential or the linear. Okay? Which function are useful for the your application, and then we can select the most appropriate function in here. Okay? So, in here we have the another coefficients. For example, W. But the I1 is directly related to the inputs of the what the X3, and so X4 is equal to what the W1 and I1. Okay, but this is the simple representation. Just remember that this is not the true, but it's in the simplest way. The neural network can look like that. Okay. Yes, it's the activation function, because if we decide anything from the input, and so we should scale it. For example, if we have this kind of function in here, like this one, with a hard nonlinearity property, and so we can condition any inputs to the 0 and the 1. Okay? And so, if you are put the high values of the x, maybe produce the what, the 1 value. But in the lowest way, it's always produce the 0 value. Okay? Because this function looks like this one. Okay? And so, if I put the theta value in here like this one, this function can be converted into the what? This denomination. Okay? But the conditions are changing. In the next chapter, I will talk about it. Okay? But how could be this structure can be converted into the what? Into the neural network body. If we have, or in analogy, in mathematical modeling, we have in here two inputs, x1 and x2. Okay? And so we have the one neuron in here, but in a linear way. Okay? Linear way. And then we have the three neurons from the previous structure. Okay? And so this neuron is directly connected to the what? To the other one. Like this one. And so also we have the N4 in here like this one. And so we can build some connections like this one. And then we have the output value in here. Okay? So this is the linear neuron, this is the sigmoid neuron, SS. Linear neuron means that the x1 is transmitted to the x1, or the some coefficients can be used in here. But in the sigmoid notation, the previous activation function should be used. And then we should also give the what? The x0 bias value, or the threshold value in here for this neuron and for this neuron. Okay? But in general case, this neuron is not built with a what? With a bias function. Okay? In this case, we have the coefficients like this one. In mathematical notation, synapses can be modeled by using some coefficients. For example, theta 1, 1, theta 1, 2, and theta 1, 3. Okay? And so in the second place, we have the theta 2, 1, theta 2, 2, and theta 2, 3. Okay? And in the second case, we have the different coefficients like this one, W1, W2, and W3. Okay? And so these whole coefficients represents the synapses. Okay? This one is nucleus. Okay? This one is the nose or the eye. Okay? This one is the what? The muscle or activation function for the heart. Okay? In this structure, this is called the standard neural network. We call it neural network, or this is called the multi-layer perceptron. Okay? Any question? Yes. Yes. Mainly we can use it, but in system dynamics, the time derivative operation should be used, which means that the output of this y should be fed into the what? Into the this one. Okay? The integration should be added in here. But in this case, we will call it the recurrent neural network. Okay? Or the Hopfield structure. The system dynamics can be modeled by using these things, but there is no guarantee to model whole the future of the equations. Okay? Okay. So, this is the basic introduction to the neural network, and then we should analyze the whole perceptron in a geometric and mathematical way. Firstly, if we have a perceptron, like, for example, we have a structure in here like this one, and so we need to bias value it's equal to the 1, and so we have the x1, x2, and blah 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 xd. Okay, we have d times input to this network, and so we have also a what the function, activation function, and then we can generate to the what the y values in here. Okay, and so each feature directly relates to what the v0, w1, w2, and wd values. Okay, and we have this information, and then y can be calculated with the what the j1 to d value in here like this one, omega j times xj, or we should start the 0 values in here like this one, or more like we should delete that. We have x1 and plus v0 times x0 in here. Okay, this is the bias value for your application, and so the other terms can be created or calculated by using this formula. But which case is appropriate for this calculation, or what's the activation function in here if the output y is equal to this one? Linear. Okay, and so if this is linear, and then we can say that this is our output. But if we choose the sigmoid function, and then we have this kind of output, x minus what, or we can give the matrix notation in here like this one, omega t transpose times x. Okay, this is the what the sigmoid output. What's the difference between the linear and sigmoid? In linear, the y can have the minus infinity plus infinity. Between these values can be considered in here, but in the sigmoid function 0 to 1 can be produced by using this function. Okay, this is the basic difference. But in geometry we have some other important relation. Firstly, in order to build your geometric representation for this perceptron, we should give the sum axis. For example, in this case, we have the x1 and x2 value. Okay, assume that these are our input parameters. Okay? And so, if we have two variables in the inputs, and so this axis considered as x2, this axis considered as to what? x1. Okay? Yes, it's the input. Okay? And so each input, one axis. And so if we add another input like this one, and so we have the what? The 3D plane. Okay? Like this one. But in this case, we should continue with the what? Two variables. Okay? So, if we have this function parameter like this one, or we have the mathematical operation in here with the summation operation, and so we can build the sum line like this one, which we call it the hyperplane. And so this nomination is coming from the what? The v0 dot 1, because the x0 is equal to the 1, we w1 x1 plus w2 x2, which is equal to the 0. Okay? This is the geometric representation of this drawing line. Okay? This line is a hyperplane, and so we cannot some parameters with some specific conditions.
What do you mean by hyperplane?
Hyperplane means that if you have the more than 3 parameters, which is called the hyperplane. Okay, it's the general meaning. This means that in this case we have a line because we have 2 parameters. But if you have the 3 or 4, it's called the hyperplane. In general meaning, we call it hyperplane. Okay. If you have a 3D geometry, and so you should create a plane, okay? But if you have the 4th order or the 4th plane, and so you need to build some 3D objects, which is called hyperplane, okay? If you have 2 axes, and so we should only see the line, because 1 dimension. But if you have the 3 dimension, and so we should give the what? The plane. But if we have the 4 dimension or 4 input parameters, and so we need to create the what? The some volume or 3D objects. And they are called, in general meaning, a hyperplane. Okay?
This hyperplane represents our predicted values.
Yes, but how? How we can do that? If you have this line in here, and so in geometry, we have 2 regions. This one and this one. Okay? If you are using any sigmoid function in here, like this one, and so we can create some boundary region in here. For example, the bottom top of this curve produce 0, and the other term produce a 1. Okay? And so, if we draw a hyperplane, one region is assigned to 0, the other is 1. And so, we can decide to each plane to what? Which is equal to the 1 or 0. Since we need to use this hyperplane to what? To cut the whole plane, x1 and x2 plane in here. And so we can easily decide the whole data is within in the what? In the 0 plane or the 1 plane. And so we can decide it by using this what? This hyperplane, using this hyperplane. Because if we use the sigmoid function in here, we can condition this area, and in the bottom top, this sigmoid function produces 0 value. In the upper part, we have 1 value, and so we can classify any data by using this nomination, as well as the what the nucleus nucleus do the same procedure like this one. Okay? Any question? In the upper part we have the 1, but in the lowest part we have 0, and so we can decide the data to what the true or false. Okay?
Classification.
Yes, this is called the classification. But if we add the linear neuron in here like this one, we can fit any data like in the previous week. Okay? But in the neural network, you should use this sigmoid function or any other functions. Okay? So, what's the point of these things? We can divide the planes or the space into the parts, which is important because if we have any mechanisms in your brain or in your data, and so we need to separate this data into the what, the 0 values or the 1 values.
If we have multiple classes, not just binary.
Just come in here, be patient, okay? I will tell everything about neural network. Don't worry, I'm here. So, the main question is that, what if there are more hyperplanes? The main question is that. So, if we have, suppose that we have the x1 and x2 value in here, x2 and x1, and so this x1 and x2 is the input of our future, okay? And so, suppose that we have the 2 hyperplane like this one, okay? This is the hyperplane 1, this is the hyperplane 2, okay?
How could we do that? Every single line is our predicted values.
Yes.
How could we have 3 lines?
Okay, this is the representation of the what, for example, x1 and x2 in here, and so we have 1 neuron in here, we have 1 neuron in here, okay? Yes, this is the h1, this is the h2, and so this is the h1, and this is the h2, okay? And so this 2 value generates the data y1 and y2, okay? But the important thing is that if we are using the sigmoid function in here, and so we can condition this line 1 in the bottom top is 0, and this line is 1 in the bottom top is 0, okay? And so how can we do that, or how can we use this information? Firstly, you need to see that this region is assigned to the 1 and 1. This region is assigned to 0 and 1. This region is assigned to 0 and 0. This region is assigned to what? The 1, 0 and 1. Okay? And so we can split the whole this space into the 4 parts right now. Okay? This is a huge advantage to what? To classify the anything here. And so, what if I add the another neurons in here, like this one, H3, and so another line should be taken in here, and then if I change the coefficients of this hyperplane in order to what? In order to classify the some things, and so we can divide this plane into different parts, which is called the what? Changing the weights means that if I change if I want to change the coefficients of these things, for example, W1, W2, theta 1, theta 2, changing to what? To classify or to separate this region in my way. For the what? For the classification problem. For example, A1, A2, A3, A4. What's the code? Changing the coefficients. What's the meaning in the neural network structure? Which we call it to the what? To the training. Changing this W1 in order to represent the proper way to classify the anything from here, and so it's called the training. Okay? And so if you are train your network, and so you only change this the direction of this hyperplane.
So we are getting more accurate hyperplane which separates between the classes.
Yes. 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 Because if we have two classes like this one, for example, and so how can we draw a line in here in order to separate this class? Yes. And so this class is equal to what? 0, 1, W1 x1 and W2 x2, and so the representation of this hyperplane is directly related to, or the function of the what? The W1, W2 and W0. Okay? And so if I have the correct choices or the right choices for the W0, W1 and W2, and then I have a trained network. But in geometry, this is just a line. Okay? Yes. 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 But in the neural network, we can also have a regression model. We can also generate to the what? To some specific signal, like the sinus or the cosinus. Okay? We can build our network by using these nominations. We get it? Everything is okay?
I have a question. Consideration 1, for example, if the first neuron decided if it is a dog or not, the second one is it cat or not. In region 1, so it is a dog and cat. In region 1, if we have a point there, so this point, this example is a dog and it is a cat.
Yes. But this have the 4 region in here. For example, if we have the XX plus or OO and star star and AA, okay? And so if we decide the whole of these things, and so if the Y1 and Y2 is equal to the 1, 1, okay? And so we can assign that this is the apple, okay? In here. Yes, but we cannot produce the Z-plane in here, Z-plane. It's the output of the these things. But in the multilayer perceptron, I will show right now. Okay? Do you have a need break, or we can continue the lesson? Okay. Okay.